Good day, y'all. We'll get settled in quickly with a few examples, more implicit differentiation. One I'm going to add in here. So let's just put it right here. I'll put mine here. Another example. We're going to find the derivative using implicit differentiation. What if I have something like, because I know I assigned, I'll go with this one. X equals the sine of y, and you're supposed to take dy by dx. We're going to find the derivative with respect to x. So if I do that to the left and I do that to the right. Now, I think we're at the point now, I'll write it up. Whether you're thinking this or just doing this, I'm fine. So if you want to skip writing this out, you're probably fine with that on a simple one like this. Sine e, sine y. Now, the left side is easy because it's a match, right? The variable x. Okay. So it's 1. How about the right-hand side? Well, if it was a match, what would the derivative of the sine function? Because you're really doing, what's the derivative of the outside function? It's the sine function, right? Cosine of y. Now you leave the inside alone. That's cosine of y. Times the derivative of the inside. I don't know what y could represent, so it's times dy, the derivative of y, right? dy by dx. Now, I haven't solved for dy by dx. I just need to get rid of the cosine of y, so I put it like this. 1 over cosine of y is equal to dy by dx. There, you've got it solved. However, I'm pretty sure the answer book won't have it that way. So if you know your reciprocal functions, and you know the other ones you should know is the quotient identities, right? Which is tangent is quotient of sine of x over cos of x. Eh? And then what is 1 over cosine? Secant, right? So, you look this up. If I said just show the, solve for it, okay, that would be okay. But then in the answer book, it probably won't say that. It'll probably say secant. Ah. What did I do? What's that? Okay, where? Oh, on the left side here? Yeah. The derivative of x with respect to x. It's an exact match there.
For the second, how do you got dy and dx?
Okay, I do the derivative of this expression, right? It's really the chain rule. The outer function is the sine function, so I say cosine for the outer function. Leave the inside alone. Times the derivative of the inner function, y. I don't know what y could represent. We're just going to say it's the derivative of the y function. Does that make sense? Now, we might actually have an expression for y. We can go with that. We're not sure what y could represent. Actually, this is getting right at the next section, actually, too. Incidentally. What is, if you were to solve that for y, what would you call it? This expression. Now, more about this tomorrow. But the inverse. And how do you notate it on your calculator? Yeah, sine -1. Y is equal to the inverse arc sine of x, or sine -1 of x. Right. Okay. Incidentally. You'll see more about that in the next day. This is a better way to solve it, actually. Anyways, then this one here, people already talked to me and they caught on to this. There is a product rule within this implicit differentiation. So maybe this time I'll skip writing the d by dx out on the whole side bracket, and then the d by dx, I can't squeeze it in here. But you get the idea of 16. Well, that turns into 0 on the right-hand side, right? Child's play. But the left-hand side is where we go. Respect to x, so we're going to have 2x. Now minus. I'm going to just write this part out as minus, just to show things, 4x y. Now, do you see this as a product when I color it like that? There's 4x times the y, right?
Yeah.
So I do the derivative of the first thing. The derivative of 4x is 4. I'm putting big brackets around here, so as far as the negative sign, I have it outside. I don't need square brackets, but I guess. Leave the second thing alone. That's the product, right? Plus, first thing left alone, the derivative of the second thing. The derivative of y with respect to x. dy by dx, okay? Now, how's that working for you? Now, I think it's very important that you put this minus sign outside on a bracket if you ever use the product rule. Because you know what's going to happen? It's going to change. This will be minus, like eventually this will be minus here, this will be minus here. If you don't do it, a lot of people tend to forget the second negative sign. So I'd say it's worth the ink. Write it down with brackets, eh? Unless you're not, if you're not prone to making mistakes like that, go for it. If you get it right all the time, I won't argue it. Y squared, so 2y, it doesn't match though, so dy by dx equals 0. Don't forget the equal 0, it's an equation, it has to equal something. Now, I think we see where this is at. Boy, you look bored. You're just tired. Okay, anything without a dy dx, I'm going to move to the right-hand side. So meaning I'm going to move this chunk by subtracting it, and this chunk minus 4y, I'm going to move it to the right by adding. I'm going to distribute, at least in my head here, minus 4x dy. So on my left, I'm left with, I'm dropping the color scheme, minus 4x dy by dx. So I'm getting all my things with the derivative on the one side. The other side, anything without dy by dx. So like I said, I'm adding 4y. Okay. How do I solve this for dy by dx?
Factor dy by dx.
Yeah, you got a common factor on the left side, dy by dx. Might be easier not to think of the two as common right now, not taking it out. If you want to right now, you can. You follow what I'm saying even? I won't do it then. Okay. I'll go dy by dx. What's left behind? Minus 4x plus 2y. I won't change the order. Okay. You guys see what we did there? You snatched that out. Now you can divide both sides by the expression negative 4x plus 2y. You could have factored out the 2 right off the bat on the 4 and the 2. I'm going to write it down as is. 4y minus 2x in the numerator. The denominator, I'm going to change the order. 2y minus 4x. Now what? What I was talking about was a common factor 2. It's on the top and the bottom, right? Yeah. So something like that you can simplify a little bit. Final answer? Sounds like a game show. So 2. And like you said, 2y minus x. I think you were going to say. Right? Okay. Sometimes people will say, well, the answer book doesn't have the same answer as this. Do you realize that if you had isolated things onto at this step, if you would move your dy by dx stuff over to the right-hand side. All your minus signs, all your negative signs would have been opposites, meaning you would have had positive x minus 2y, positive 2x. That's the same expression. If you ever look something up in the answer book and the signs are exact opposites, numerator, denominator, you have the right answer. Multiply it through by -1 over -1 if you wish. It's the same thing. Okay? That's all I'm just saying. You isolated on one side, whoever did the answer key isolated on the other side. That happens sometimes. And there's nothing wrong with your answers. Okay? Now, so the product rule is, the whole reason why I'm doing this is the product rule. It's a possible mistake. And then I wanted to try implicit differentiation for one more thing. And turn you loose again. Solving for the second derivative. Let me see here. Okay, 2x cubed minus 3y squared equals 8. Now, if it doesn't involve a square root, you can solve these for y, but this, if you solved it for y, it involves a positive and a negative square root. Don't solve it then. And actually, I find implicit differentiation easier than working with square roots. So I do the derivative of the first thing, the second, like the left side and the right side. We're going dy by dx. So 6x squared minus 6y, and then the derivative of the inside, dy by dx, because it was a mismatch. Now, is there any mystery there? You can write y prime, it means the same thing, dy by dx. I like this, oh, it's terrible long. You guys have it rough. Now, just keep it straight too. This tells you exactly what this notation I like better because it tells you you're doing the derivative with respect to x. Whereas y prime, yeah, it works, but it doesn't tell you what the variable was. But it's the same thing, I won't mark it wrong. So y prime just fine. I guess I'll keep the 6x squared on the left side because it's positive already. Now, I'm showing all the steps here. If you want to jump straight into this, that's fine. dy by dx equals 6 over 6 cancel, right? X squared over y. Now, that's only the first derivative. I said find the second derivative. Son of a biscuit. Got more work to do. And this involves the quotient rule. Quotient rule. What? Quotient rule. Yeah? Say it again. Quotient rule. Okay. So now, I take the derivative of the left side and I call it d2y. And this is the proper way to notate it. d2y dx squared. Okay? Now, notice that the 2 comes on the inside and then the y. Anyways, that's all nitpicky and stuff. Derivative of the top, 2x. Leave the bottom alone. Subtracting the top left alone. The derivative of the bottom, 1, dy by dx.
Why is 2y?
Sure. 2x, y. Thank you. Because I made a mistake. That's why. Ah. That's why. Thank you, Zach. 7 brownie points for Hufflepuff. I told you were Hufflepuff, right? I can tell by your hat, sorting hat. Hi, Jillian. Okay, square the bottom. So you know what you are. Okay. Do we have this solved? shouldn't have a derivative inside the derivative. We can. But we actually have this solved. We can sub this in. Do you guys follow that? Oh, yeah. Just checking it. Okay. So I'm going to sub in. And so I'm going to have, for a moment, I'm going to have a fraction inside this fraction. 2xy, subtracting x squared over y. Yuck. And you look at the back of the book. Okay. At this point, if I didn't say simplify or something like this, you're done. Sure, it's a yucky expression, but it's, you don't have any dy's by dx's in your right-hand side, right? So you'd stop here. But,
Give a fraction. You much better simplify.
yeah, that's exactly what I'm getting at now. Couple things here. So, chances are, though, you might have this on a multiple choice kind of question where you're going to match it up to a bunch of answers and they don't look like this. So, two things that we're going to do. One was already mentioned. If I'm dividing by something, isn't that the same as multiplying by 1 over y squared? So it just makes it easier. I just think of this. 1 over y squared. Then the rest of the expression. That's even if I don't change anything inside there, that's still the same, right? Now, within the numerator portion of this expression, this numerator, we need a common denominator, do we not? Yeah, we do. I'm telling you we do. So, multiply by y, top and bottom of the 2xy. I was going to pull out a common factor of x right now, but I was thinking, no, your head will explode or something. Okay. So, what I'm going to do is multiply y here and multiply by y here. Do you follow that? Okay. So, what do we get? We get 2xy squared. Okay. Now you said it that way. I like doing it this way though. What you said is not incorrect. 2xy squared over y minus x to the 4 over y. Nothing you said was incorrect. I'm just not going to skip as many steps. Okay. So yes, it has the same denominator. And can you group anything on the numerator? No, absolutely not. You could do some factoring business, but let's just toss it in. I don't know why I changed color. Just grab it one. 2x y squared minus x to the 4. Oliver, y cubed. And that would be it. You could factor out the common factor of x on the numerator. That's about it, though. I'm going to just stop it.